Hey, people are still hopping on, but I'll go ahead and get started. Welcome to the 53rd episode of our monthly virtual seminar series. We started these webinars as a place to ask the clumsy questions, to practice bravery and humility, to have conversations, and we're very grateful for the community that you've built around them. If this is your first roundtable, all you need to know is that they are designed for contribution, not consumption. And as a reflection of that intent, the panelists have been given only about 12 minutes each to make some introductory remarks, allowing our last 30 minutes entirely for discussion and conversation. I usually start by describing a little bit why this topic at this time by these speakers. And luckily, this topic needs really no lengthy introduction. I think it's difficult to live anywhere near the Chesapeake Bay and not recognize the iconic importance of oysters from being part of the identity of a resident. And I'm stunned by the number of decorative home items based on oysters to their ecological value. Just a few facts: oyster reefs provide food and shelter to more than 300 other species of fish and invertebrates. And prior to the 19th century, the population could filter the entire volume of water in the bay in a matter of days. That role extends to storm protection. Changing environmental conditions are expected to put at risk more than 110,000 homes in Maryland and Virginia by 2100. Their economic value is substantial, and with a single acre of restored oyster reef providing services worth up to $40,000 annually, not including harvest. And one of our speakers might be able to give us a little more specifics on that number. But here's a welcome piece of good news. Restoring native oyster habitat and populations in 10 tributaries is one of the few material outcomes in the Chesapeake Watershed Agreement that will actually be achieved this year. But here's the challenge. We're at a pivot point for recovery of the Bay's oyster population, which with much farther to go. And so in the words of our colleague, Don Bosch, this is the beginning, not the end of oyster efforts. Our restoration achievements today have been made possible through strong federal investment, state support, and the collaboration of many partners. And as our last webinar discussed, the future of investment is a little more uncertain than it used to be. So how do we remind ourselves on the return on investment, and what are the steps forward? And so our speakers are uniquely suited to guide us. Matthew Woodstock, I think he likes to be called Matt, appears to love anything that swims in salt water and specializes in ecosystem-based modeling of aquatic systems. He's got a long list of computer language proficiency and a love of exploring networks and relationships, especially between fisheries and economics. We're going to put a link to a wonderful paper he wrote in the chat. And I think what makes him a little bit unique is his strong support of open science, with an invitation on his webpage for collaboration and access to code. And I think he's emblematic of a new generation of scientists that have really accelerated the ways in which we pursue discovery. He also appears to go to work on Virginia Key and Biscayne Bay, and so I'm wondering if he snorkels at lunchtime when he's in the, well, and he's also now working in the Gulf of America. I just want to remind everyone. Bill Walton, and if you're from my generation, he's not that Bill Walton of the Celtics, but he comes with a lifetime of experience in supporting shellfish aquaculture with interest in all aspects, including opportunities for public fisheries and restoration. He's also a unique scientist with an Instagram account with the wonderful byline of "Have Shucking Knife Will Travel," and has approximately 2,800 followers. He has a wonderful way with words. His lab is called the Commercial Shellfish Aquaculture Lab and Team, or wait for it, sea salt. So with that, I'm going to turn it over, and Matt, you have the floor.
All right. Thanks, Denise. I do not snorkel on my lunch break. We have a resident crocodile that would love to um yeah, upset that. So is my screen all good? I'm assuming.
Yes.
Cool. All right. Well, Yeah, hi everyone. Again, my name is Matt Woodstock. I'm a researcher at the University of Miami's Cooperative Institute. I'm an affiliate with the NOAA Southeast Fisheries Science Center as well. Today I'm going to talk about a study that we did when I was a postdoc at Morgan State University's Pearl Lab. And that study focused on the ecological and economic impacts of oyster restoration within the Virginia Middle Peninsula, particularly in respect to the regional economic impacts of the commercial fishing industry. So I'll note that we had a really interdisciplinary team of ecologists, modelers, and economists that included two PhD students, Amanda Bevins and Mohammed Sullivan. And they did the main share of the ecological modeling work. I just kind of overseed that. We also had an external advisory panel that helped us steer in the right direction, as well as set up some of the scenarios for us to run. This was a decently complex project, so I'm not going to be able to discuss it all today. But we did publish a piece of that work earlier this year as a pretty lengthy methods-based supplement. So the QR code will take you to that paper. I also believe that Abby's going to put that in the chat. But obviously, oyster restoration in the bay has been a large investment, and the initial planned restoration efforts are complete in many areas, including an additional 53 acres within the Piankatank River. And there's also ongoing restoration within the Mobjack Bay, which is in the Virginia Middle Peninsula, but wasn't part of our study. Now, monitoring results out of Maryland have shown that most of the restored reef areas are meeting density, biomass, and shell budget targets, which is a positive sign. And our team set out to understand what the potential economic effects of this investment could be. So coinciding with oyster restoration is ongoing changes to submerged aquatic vegetation coverage of particular importance to our study, eelgrass and widgeon grass. These plots have total SAV coverage in the York and Piankatank rivers over the last 40 years. And you can see it's not close to the original SAV target goal, and that there's also a fair bit of interannual variation in the recent years. Eelgrass declines have been observed and are believed to be a problem of water quality, nutrient loading, and water temperatures, which are obviously ongoing problems in the bay. Now, when eelgrass vacates an area, widgeon grass tends to move in. It's a different kind of seagrass, but it doesn't serve the same ecological function as eelgrass does. Now, these rivers both have commercial fishing operations that are targeting species known to either associate with living habitats or consume prey that do. The York River is the largest of the two and also has far more fisheries harvests, generally an order of magnitude more in both poundage and harvest dollars. So overall, the entire region is supplying millions of dollars per year in dockside sales. And unsurprisingly, blue crab is the dominant commercial resource, making up the majority of the annual sales, while wild oyster harvest is another lucrative resource. Now, one of our objectives was to predict how these commercial harvest values may change with continued changes to oyster and seagrass habitats as a result of ongoing restoration efforts. So it's important to note that this isn't including aquaculture production or recreational harvest, because our focus for this study was specifically the effect of changes to the wild population and commercial fisheries impacts. But our studies other studies could explore that impact of the industries, and I think that'd be really neat. So for our project as a whole, we had three main objectives. The first was to develop two different ecosystem models in the Middle Peninsula, one in each of the rivers that I've mentioned. The second objective was to interview watermen from the region to understand more about their annual expenditures through a semi-structured interview process. And then the third was to combine the results of the first two objectives in an economic impact modeling effort to predict the regional economic impact that changes to living habitats may have for the commercial fishing industry. And when I say ecosystem model, it means that we considered food web dynamics, species life histories, fisheries, and environmental factors into one model to ideally recreate realistic population and harvest trends. We used EcoPath with EcoSim, which is a software that's commonly used for this type of modeling. It's also being used to inform fisheries assessments in other areas of the US, as well as the rest of the world. Without going into many of the modeling development details, we take information about harvests, biological rates, and diets to create a food web, which is depicted in the top right plot. We then integrate environmental factors to add seasonality to the model, and then we calibrate the model to observe time series. And the idea is that predator-prey interactions should be reflecting realistic dynamics, such as the fact that prey are not always available to a predator, like is shown in the bottom plot. So, for example, prey may be in the middle of a school as opposed to out on the fringes, or they may be hiding in rubble as opposed to being out in the open where they can easily be picked off. So, oysters in this case, again, it includes aquaculture as part of the initial biomass since they do provide ecological services, but we didn't change the aquaculture oyster biomass throughout the simulation because we would have had to make assumptions about how that industry progressed. Now, once we had an operational model, we then applied various scenarios. Three of those scenarios focused solely on changes to oyster populations. One scenario simulated our post-restoration system plus additional reef growth, which was informed by post-restoration monitoring efforts in other restored rivers. Now, since restoration ideally leads to spillover in other natural reef areas, this also could be considered a growth plus spillover scenario, regardless of any management decisions around fishing on restored reefs. But mathematically, they'd be equivalent in this context. We also had a simulation where oyster populations stayed at their post-restoration state with no additional growth, somewhat as a control. And then finally, we simulated how the system would change if oyster restoration didn't happen at all. We then simulated eelgrass population scenarios showing increases to the maximum coverage since 2000. We showed constant coverage levels, and then we also simulated decreased eelgrass population trends, equivalent to a bay-wide eelgrass trend that has been noted in the literature. So since there's a known inverse relationship between eelgrass and widgeon-grass, when eelgrass decreased in a scenario, widgeon-grass increased and vice versa. Now, EcoPath is mostly adept at simulating food web processes, so we needed to include the non-consumptive effects that these habitats have, like animals that associate with these habitats for space for settling or any other reasons. So for species that are known to rely on these habitats for non-consumptive reasons, we also changed their biomass according to the habitats so that we could truly get the ecosystem level effect. Now, finally, we ran three scenarios where we combined oyster and eelgrass population changes. These included scenarios where oysters and eelgrass increase, one where both habitats decreased, and then a third where oysters increased and then eelgrass decreased, which we considered our anticipated current situation with everything going on. And we ran each scenario for 20 years. And we get a lot of interesting ecological results from these models, but I'm going to solely focus on the economic focus results, mainly changes in annual dockside sales with time. So in all plots, the brighter yellow line represents the optimistic scenario where living habitat populations increase. The pink line represents the scenario where habitats didn't change. And the maroon line represents a more pessimistic scenario with the worst habitat situation. So since blue crab is the dominant commercial resource, I'm focusing on their harvest here for the next few slides. But other fisheries followed a very similar trend. Now, the main result is that more oysters means more annual harvest, while less oysters means less dockside value produced. Since these results are annual estimates, continued restoration success and the resulting increase in dockside sales actually would have a compounding effect on the total cumulative increase in dockside sales over time, kind of like continually adding money into a bank account that doesn't really accrue much interest. So eelgrass scenarios produce a similar result where more habitat equates to greater harvest revenue, except that potential gains and the potential losses are greater with predicted change in habitat coverage. So our model predicts that restoring eelgrass to the recent maximum levels in both rivers could nearly double the blue crab harvest. The harvests in other areas or with other species like striped bass also responded very favorably to successful eelgrass restoration or the addition of an eelgrass-like substitute. So when we combine the changes in living habitats, we get something pretty interesting, and that is the increases and decreases still have a similar story. But when we see successful oyster growth post-restoration, but continued declines in eelgrass, we actually predict there to be a slight, very slight decrease in blue crab harvest that's similar to the post-restoration scenario kind of status quo. Now, I want to be clear that status quo line is still the post-restoration status of oyster reefs. So this isn't saying that eelgrass needs to be maintained for the restoration effort to be successful, but to continually increase gains into the future, eelgrass restoration is important. So aside from our harvest predictions, we interviewed watermen about their annual expenditures for our larger economic analysis. And the reason these interviews were so important is because the economic model we used in Plan has a commercial fishing industry preloaded, but the cost structure of that fishery doesn't accurately reflect the small scale fisheries we see in the Chesapeake Bay. This effort ultimately resulted in this table with each gear as a different column, different cost categories as rows, and the values are mean percentages from all interviews. Aside from personnel expenses, repairs and maintenance, and fuel were consistently the largest expenses among years, with bait being an important expense for crabbers. And this is pretty typical to what we would have expected. Another large category is income costs for the owner and the crew. And there was a fair bit of uncertainty here, as some watermen had crew, others didn't. But a caveat to note is that this is considered the average annual expenses. So it doesn't include one-off expenses that may go into a rainy day fund. Now, another anecdote I wanted to share is that many of the watermen didn't or did express a lot of concern over their ability to cover expenses in any non-typical year because those one-off expenses can be so large. And this information was used in our final analysis to inform an economic model called IMPLAN and relate the simulated harvest values to the regional economic impacts of the commercial fishing industry in terms of both jobs and dollars supported. And this is an overview of the change in direct costs of each scenario. And that includes the impact of all fisheries for both rivers combined. Direct costs is an economic term that in this context is equivalent to the jobs and dollars supported in the commercial fishing industry through dockside sales. And based on the at least one habitat, the direct costs increase, and these gains become more successful as restoration is more successful. We can also add in the effect of supply chain related expenses beyond the immediate fishery, and those are called indirect costs. Now, when we consider the broader supply chain supported by the commercial fishing industry, the potential gains and losses get larger for each scenario. Now, finally, we can add in induced costs, which is the jobs and dollars supported by spending of income earned by the industry. And again, all of the potential gains and losses get larger. It's important to note that one, all of these values are annual. So the mature reef in the top right corner would be $1.2 million gained per year relative to the base scenario of the young reef and the current eelgrass levels. But also, too, these values are from the end of each simulation. So it would take time to reach these gains. Now, I want to leave off with this figure that summarizes the main point pretty well. Even if we were to consider just blue crab harvest, successful oyster restoration can increase the economic impacts of the commercial fishing industry by millions of dollars per year. However, this number is reliant on the success of both oyster restoration and the future of eelgrass. Successful oyster restoration and the continued loss of eelgrass minimizes the potential gains, although it is possible for the declines in harvest to exist with declines from restored reef level. Our prediction suggests that there is a greater opportunity for gain than loss. But the realized gain and loss that we actually see is going to be reliant on the actual success of the restoration effort over time. So we're grateful for a lot of people, organizations that listed here to by either directly communicating with us or they hosted their data publicly. Huge thanks to the watermen I interviewed that helped share information about the fishery and for this project. We had a great advisory panel that gave us a lot of advice. And finally, this project was funded by the NOAA Chesapeake Bay office. And I look forward to any questions at the end.
Oh, hey, thanks, Matt. Can you go back one slide and that the green number on the most gain,
Hmm.
the figure above it is a little hard to read in the green.
Yeah.
Can you just, what is that?
Yeah, so that's a 122% increase in harvest.
Okay.
So that's the harvest amount, harvest value. And then the bottom value is inclusive of the indirect costs and the induced cost.
Okay,
So
great.
the
And what,
full industry.
yeah, what is the number?
Uh,
53 million?
the 3.1 million per year is the most gain on the bottom.
Yeah. Thank you.
Yep.
Thanks very much, Matt. Bill, you have the floor.
All right, let me see if I can successfully share a screen. Step one.
There you
All
go.
right,
It's
great. Well,
yep. It's
there we go.
there. There you go.
Great. Well, thank you. And Matt, that was wonderful. It's certainly it's exciting to hear about that and thinking about the economic benefits of restoration. I'm going to change gears a little bit, and what I wanted to do was, in my experience, I come from a background of working with fisheries, restoration, and aquaculture, and the last dozen years or so have been focused mostly on aquaculture. But thinking about shellfish aquaculture as practiced commercially as a restoration tool. And so, if I'm gonna if you want to scan that, you can go check on that is the sea salt research farm in the York River. So Matt was just talking about the York River. There should be a live oyster farm cam that you can see. Hopefully, they're all still they're still looking like what they do in this video. So you might look at that, and certainly this is a research farm, but this is not necessarily atypical of what a commercial shellfish farm would look like. And it's structure in the water. And it is, for a commercial farm, this is often, I think we would look at this and think of this as a way that, like a farm, somebody making a living. Having been around a number of these farms, I do see these as really alive places that have a lot of ecology going on around them. And so I wanted to share the perspective of thinking about shellfish aquaculture, not just as something that has economic benefits, but thinking of some of the environmental benefits. For those who do care, I wish I know this is a Chesapeake wide. I don't know for Maryland, but as a starting point in Virginia, it is economically important. We know that there are hundreds of jobs in shellfish aquaculture in Virginia. Of course, those are all concentrated around Chesapeake Bay and on the ocean side, the seaside of the Eastern Shore. Uh, it's about a $50 million farm gate industry. Even if conservatively with an economic multiplier of 2 to 4, that's a fairly large number, particularly when you place it in the context of some of these rural coastal communities. This becomes one of the main industries in a place like Eastern Shore of Chesapeake Bay. It's important to the local economies, and I think just on the human level, it's something that we find that young people look to as a potential career. So let's go stepping back. When I started thinking about restoration, I was particularly taken by, I apologize, the values of aquaculture to people and nature, thinking about ecosystem services. And so, for those who aren't familiar, there are these ideas of, sorry, I did not take off animations on this, the provisioning, regulating, cultural, and habitat supporting. And so, the Alloway et al. Is an excellent paper in that regard. So when I look at this, to me, shellfish ecosystems are something, and I'll just have to keep clicking back. I apologize. Shellfish ecosystems provide a number of ecosystem services and at a greater magnitude. But when you look at shellfish mariculture or aquaculture, you'll see that there are ecosystem services provided there as well. If I go back one for you, the regulating ecosystem services, things like denitrification and filtration, sediment stabilization, those are something that we do see shellfish aquaculture showing up as contributing a good deal to. So, thinking about the obvious one is provisioning. So, food. So, we know that shellfish are nutritious, they're high in omega-3s, they're loaded with vitamins and minerals, great natural source of zinc. And they're also a non-fed animal crop. And I think I'm going to come back to that as something when we think about animal proteins. And I think probably everybody has seen this, that shellfish help water quality, shellfish graze down excess algae. I've struggled with people who want to eat shellfish as maybe not being comfortable with this concept, but to me, this is like putting sheep into an overgrown pasture. They are grazing down the extra phytoplankton in the water. So obviously only harvested from waters that are considered safe for human consumption. They're also part of a healthy ecosystem. And so, Matt talked about SAVs, oysters. We know that oyster and mussel seaweed farms increase removal of nitrogen. And you can see that there's some estimates of how much that is. I've actually shared the Barrett et al. Paper with Abby, and she can put that in the chat if she hasn't already. And then thinking about shellfish aquaculture may reduce erosion. And I put may in here because I will say that I don't think there's a lot of great data for this, but you can see in this picture that when you look, I know this is simply wind waves, but you can see in that picture that there's a substantial knockdown of those by these structures. And then there is also this idea of shellfish as habitat, and we can talk a little bit about we could talk a little bit about this afterwards. I do think it is important that shellfish farms, they need to be increasing productivity to be considered habitat. They cannot merely be attractive devices, but there are estimates out there of increasing by hundreds to thousands of dollars per acre in terms of commercial fisheries. When we look at rural communities, I've got to stop there because that's actually my teenage son who jumped in the water and worked at a farm in North Carolina. This is a way that we do find that shellfish farms give community a sense of pride and place. And if you think about a lot of our rural coastal communities, I do think that we can think about, oops, resume that. You can think about whether you'd encourage young people to go into commercial fishing. And I would say that in many communities, that's not happening, but we are seeing people encourage people to go into shellfish farming. A colleague of mine, Adrian Michaelis, her references at the bottom of this slide, has done work on the cultural ecosystem services that are enabled to work with shellfish, which include shellfish aquaculture. And then again, I just wanted to go back to this. It is one of the most sustainable ways to produce animal protein. And if we're going to continue to eat animal protein, then I think we need to be thinking about how we produce that animal protein in a sustainable way. And I think probably everyone here knows you don't feed shellfish. That means you don't medicate shellfish. And I think maybe importantly, as the climate changes, very little potable water is used in the production of this animal protein, which I think stands in stark contrast to some of the other options that we have out there. So I went through that faster because of the animations that I meant to, but I'm glad to answer any questions. And I hope that taking a step back and thinking of this from maybe a 20,000 foot view is appropriate for this audience. So yeah, as I think Denise mentioned, I've got an Instagram account, and then Vim Shellfish Aquaculture is available as well.
Oh, thanks, Bill. And thanks to both speakers for being so time conscious. And sorry, Bill, that was challenging, I'm sure.
My fault. It's completely my fault. I apologize.
But I actually liked the preview of the next slide. So to remind everyone, please submit your questions on the chat. I have some that were put in beforehand, but we love to see them in the chat. So I'll give you a minute to do that. I have a question actually for both of you, and this is my own question. What is sort of happening currently with the use of aquaculture for nutrient trading credits, Bill? Do you know
I
anything
don't know,
about that?
Matt, if you've got information. My knowledge of that is that it's certainly been something that's been, there's been a great deal of interest in this idea that if shellfish farmers are going to grow shellfish and then harvest those shellfish, so that we're removing nitrogen, is there some way to give them credit for that? And the idea would be that that would be a nice incentive for them to continue to do that work, maybe make their businesses more economically viable, more sustainable. Generally, I think there's interest. I like the concept. The math has been complicated enough that we certainly haven't seen that widely adopted anywhere. That doesn't mean that it's not a good idea, but it's not been something that I've seen that's moved to what would be truly nutrient credits. It's been more focused on the idea of shellfish aquaculture gaining what you might call social license by just increased understanding that shellfish are helping clean the environment. I will say for those, for those who eat shellfish, I have struggled with that messaging of shellfish clean the environment, and by the way, would you like to eat some? That I think that probably many people on the call understand those differences, but I think that can be a challenge for people who are trying to sell shellfish for consumption.
Mhm.
Yeah. I mean, everything I know about the nutrient credits is from what articles I've read. So I don't necessarily have expertise in that area. But it sounds like it could potentially be a win-win if the math is done right and it works well.
Yeah.
But I know there's some initiatives to do that. I believe in Calvert County, Maryland is one of them. I believe there's an initiative or at least one farm that is working with the county to try to get um, credits from the state. So it could be a community-based initiative that's pretty neat.
Mhm. Okay, we've let me read. We had a really great question in advance, and I think it's something to really talk about. What can you sort of characterize if there are, and how we might address spatial impacts and conflicts of either native shellfish restoration and aquaculture going into the future? You know, are there spatial conflicts? To what extent are those sort of challenging?
Hmm.
So uh, Matt, do you want to go first on this one and then hand it to Bill or?
Yeah, I can. I mean, there's certainly challenges anytime you have multiple industries operating within the same area. I do think it's important to highlight the potential benefits that oyster restoration and restored reefs could have on the aquaculture production, but also how aquaculture can um, help with the ecological benefits, make the rivers healthy. Because ultimately, restored oysters or restored eelgrass, as I talked a little bit about, it's reliant or its success is reliant on having a healthy environment that allows those animals and or plants to continue growing. So, we can put money at the problem and restore things, but if the environment is not set up in a way that allows those animals to continue growing, you're not going to see the maximal effort or maximal economic benefit that we may predict right now.
Yeah, I concur with Matt. Certainly, there can be conflicts. Um, SAV and shellfish aquaculture, we need to think typically you can't put shellfish aquaculture where there is SAV, but then you can have
Mm.
areas where SAV moves in to areas with shellfish aquaculture. And you could imagine that as as SAV restoration continues, that could expand into more areas and the shellfish aquaculture industry might want to expand. So you can get conflict. That said, I think um, there are ways to resolve that. I think some of that is with the permitting. I think some of that is, I do think there's value in thinking of the system from an ecosystem services and not being stuck on that there's one tool that gets us to the most ecosystem services. If we put it in that currency of we want the highest, functioning system with the most ecosystem services, how can we get there? And as a cartoon, like a very simple level, you could imagine with oysters that in a low salinity area where there's not high levels of productivity, you wouldn't probably do shellfish aquaculture, and you might not even have a vibrant fishery there. But that might be an excellent place for restoration because, for example, disease and predation might be lower in that. That might be an excellent place to invest in restoration. Mid salinity area could be an area that a commercial public fishery could thrive, and then high salinity areas could be an area where maybe restoration wouldn't work because disease levels are high, but shellfish farmers are moving their product through quickly enough and they have disease resistant stocks. I could imagine that cartoon as adding up to more oysters in a water body like Chesapeake Bay, which potentially gives us all more ecosystem services. I, I'm not arguing specifically for Chesapeake Bay, but just generally thinking about oysters and how you might try to reduce some of those spatial conflicts.
Mhm. Let me ask this question, and I don't know, to see, Ryan Corbin asked, where do oysters stand as far as BMPs for jurisdictions to use for TMDL crediting? Are there any options for jurisdictions to cost share with watermen on leased ground or aquaculture facilities to split cost for lease and seeding where jurisdictions can claim the nutrient credits and watermen aquaculture farms claim profit from harvest? I think we addressed that a little bit. I know Maryland, as of a couple of years ago, was trying to initiate a nutrient trading program for oysters. And Bill, I know you're in Virginia, but
Yep.
Anything more on that to add on that about, this idea of jurisdictions sort of cost sharing with watermen on leased ground?
I would say there's certainly interest in Virginia. I recall a similar effort in Massachusetts on Cape Cod, where there was a lot of concern about wastewater and how communities could start to meet those TMDLs. So I know there's been interest. There's been, I have not seen that turn into something where a community is using that, but that may be my ignorance.
Along with that, are there any drawbacks to increasing aquaculture?
Matt, do you want to go first or?
Um, well, I mean, other than the potential spatial conflict, I I don't really have any off the top of my head. Bill, you're more involved in that, so you might have some
I mean,
more.
yeah, certainly. I have heard people share concerns that if you look at countries like China and you look at some of their embayments, you see almost like a carpeting of the bay with shellfish. This is my personal opinion, with the labor costs that we have in the United States, I don't think you could. Shellfish aquaculture is so labor intensive that I just don't see that you could ever, no matter what the permitting environment was, I just don't think the economics of it would work to scale up to something like you might see, for example, in China.
Mhm.
So I think there's certainly tremendous potential for shellfish aquaculture to increase. We have vast amounts of bare of the bay that is bare bottom. It has, no SAV on it. Areas that we could find out of conflict. There is certainly the potential to increase that. There, you'd have to be aware of conflicts with user groups, and then the other consequence is that you can grow shellfish, but you also the shellfish farmer needs to be able to sell shellfish, and so there would be market consequences. If we dramatically increase production, you'd have to then also increase the market.
Billy, you're on the hot seat. There's a lot of questions in the chat. So, and Matt, please, just feel free to add your bit. Um, this is interesting. And actually, I think you could both answer this. Are there any ongoing organized efforts? And the question is for Virginia, but I'd say anything to educate the general public and adjacent homeowners more to the ecological benefits of shellfish aquaculture farms. Maryland is still struggling with public opposition that seems based mostly in fear of the unknown and misunderstandings about the industry.
Yeah, yeah. So I mean, as you mentioned when we went off, I live in South Florida now, so um, I'm not quite on the ground and reading all that news and up to date. But I do know when I was living in the area, universities were really trying to push and different organizations were trying to push the benefits of these. I don't necessarily know how successful um, those efforts have been, but I think it comes down to, as we had mentioned, highlighting the ecological benefits that different user groups could have and really highlight the potential win-win situation that could exist from both efforts. Um, but yeah, that's always a tricky topic.
Hmm. Matt, have you and then we'll go to Bill, but have you been recently engaged in sort of this valuation of, I mean, I know you looked at catch data,
Mhm.
but the value of the additional ecosystem services, um, especially in the study that you did in the middle?
No, I mean, we looked at biomass changes over time. So there wasn't really much of like a nutrient component to the model. So we're not really capable of looking at those types of services from increased oyster levels and all that. So no, we largely focused on commercial catch, but then also biomass increase as there's more habitat.
Mhm. Bill, are there any ongoing organized efforts for
You know,
educating the general public?
yeah. It's a great question. It's one of those things that for anybody here who does shellfish aquaculture or works around it, it's one of those things that you probably talk about all the time. And so when somebody says like, you should really tell people about this, you think that's one of the things you can tell people, but of course it doesn't mean everyone hears it. And it's just something that I think people are not that familiar with. I think it's very easy when you talk to the general public. They talk about trapping oysters. Are those oyster traps? Are they like there isn't necessarily that awareness or understanding of what shellfish aquaculture is, which maybe shouldn't surprise us when you think about how familiar most Americans are with terrestrial agriculture. Um, that said, I will say there are groups out there, certainly the universities, I think, are trying to share that, not to argue for shellfish aquaculture, but to give communities the best available science about it, to let communities make informed decisions about it. Um, the so there are efforts that there are certainly industry groups and nonprofits that are doing that. One that might surprise people, the Nature Conservancy, has been a strong proponent of shellfish aquaculture as part of the restoration solution. If you go to their website, you'll see quite a bit about commercial shellfish aquaculture is something that they're supportive of. And just as a for the general public, I've seen at least two commercials now for I don't remember what the commercials were for, medicine and something something else, but where the people were on shellfish farms. Like there was
Mm.
some medicine and the people are out going on a shellfish farm eating shellfish. They take a boat out and they go out and another one's is something about somebody is a shellfish buyer. And I can't remember what the ads are for, which means they're probably not very successful, but they've set that they have used that as a backdrop, which I think to me has been a sign that maybe there is a little more awareness of what shellfish farms are, which then leads to the conversation about are there ecosystem services that are provided from these?
Mm. Great. I will note for people that don't see the chat that Jeff Corbin had actually answered the question about TMDL credits and BMPs, and there's two, one for caged aquaculture, the other for restored reefs. So if I would imagine if you can go to the Chesapeake Bay program, you can find that. Matt, there's a question for you. I think you answered it a little bit in the chat, but I just thought for everyone on the call. And it was in the modeling, did you observe SAV habitat increased with the restored oyster reefs? So as, turbidity was lower, seabed rose, more light reaching the bottom. Was there
Yeah.
any?
Well, so that's a really great question, and it's an interesting one. So our model was pretty strictly a food web model. So we didn't really have the effects of turbidity or nutrients looking at the any sort of non-consumptive effect or any sort of mediating effect of like oysters and eelgrass. Um, Hypothetically, it's something that could be done in a model like this. I would probably actually choose a little bit of a different software. Some of the other ones I use that are more focused on like biogeochemical fluxes, and then you really get into the nitty-gritty of nutrient pools and nutrient fluxes.
Mhm.
But that's actually the main reason why we had so many different scenarios. And we had multiple scenarios that I didn't actually show you today. I kind of just showed you the best ofs. Because we weren't able to get that non-consumptive mediating effect or the influence of oysters on the turbidity in the water column, which influences seagrass, we kind of needed to have a proxy for it. So that's where you could see like a scenario where if you have increased oyster populations via restoration, you could potentially see an increase in SAV over time as well. So that's part of the reason we had some of those scenarios. You could also have like an increase in SAV via restoration, but they're more of the interpretation of those scenarios is more of a proxy to describe the math that's going on in the model, which is habitats either increasing or decreasing.
Mhm.
Hmm.
Um, Bill, I love you answered this question in the chat, but I thought it was so interesting. You seemed hesitant. I love when people can read your facial expressions when you're on Zoom. You seemed hesitant to claim oysters may reduce shoreline erosion. Were you hesitant?
No, and to clarify, I clarified in the chat, but for everyone, I'll say that what I was talking about was oyster aquaculture. That I have not seen, I haven't seen wave tank studies, nor have I seen field studies that show that if I put floating gear in the water, that it will substantially reduce wave action and therefore decrease shoreline erosion. Uh, to the question, I'm blanking on the name of who posed the question. I apologize because it was a good point. I would say there are good data that show that oyster reefs can do that. It does depend a little bit, of course, on the shoreline orientation and the depth and whatnot, but we know that they can. Um, my experience has been on shellfish farms. I can be on the backside of the shellfish farm and certainly know that I'm in less choppy water than I was on the front side of the farm. But again, I
Mhm.
haven't seen that translated into shoreline, any changes in the shoreline. I want to allow that it could, but I'm just saying that it's not something that I'm confident that I can stand behind confidently.
Yeah. Can you each kind of remark on the kind of largest challenges, Matt, either to restoration and or aquaculture, if they're economic or otherwise, and Bill, just sort of logistically in terms of, um, you know, disease, just how vulnerable aquaculture populations are. So, what are the biggest challenges actually, if we're at this pivot point to using both techniques to get, and like Bill, I like the way you put it. If we were to come up with a system where we're gaining the most ecosystem services, overall bay wide, what are challenges to accelerating aquaculture restoration both?
Matt, you want to jump in on that, or
I actually don't have an answer. Yeah.
yeah. All
I think
right,
the
then
appropriate answer is I don't know.
all right. I mean, I think there are a number of challenges. When I try to think of what the biggest ones are, I think certainly um, these are all risky ventures, right? I mean, these are living organisms that we're investing in, and we're doing our best to choose sites, whether it's restoration or aquaculture. We're choosing our best to maximize the likelihood of success. But we know that we get different years with different winters and different rainfall in the spring. And then there's long-term changes. So sites that we thought were good may be changing. So I think um, it, and again, these are risks that are worth taking, I believe. But um, they are living organisms, and so we know that there are things that are beyond our control, but we need to be aware of those and be responding to those. So if we can see consistent changes, we need to be thinking about that. I think we have solutions with restoration and aquaculture to some of the challenges like disease. I think we can do resistant stocks. I think there are refuges from disease for restoration. I think there are different approaches to that. Um, so to me, it's probably sort of the will to to allow or push these things forward, whether that's a restoration effort or whether it's aquaculture. I think in some ways, I think it's the public support or lack of support for those things that I see, frankly, as the biggest challenges.
Mhm. Matt, you have the enviable, I'd say, position where you can talk about economic value, which is something a lot of us ecologists wish we could do.
Hmm.
So, do you see in sort of giving, given the existing changes in sort of support for bay improvements, whether they're political or I think it, how powerful is the economic argument? Do you find it resonates like with policymakers, and how do you talk about it? I mean, if you could do anything to sort of make it more impactful,
Hmm.
what would you add?
Yeah, it's a great question. So I will say most of my work has been very ecology focused. We focus on changes in population trends over time, or you know, sometimes be carbon movements and that. Now, the reason I really wanted to join this study when it came up is specifically because we're linking those ecological trends to dollars, which what I've found after leaving that study is that's really what most people want to talk about. most people that aren't ecologists, that they want to talk about dollars, they want to talk about jobs, they want to talk about how this is going to impact the local economy. Now, our study focused on just one industry, the commercial fishing industry. It's a big one, but there's others. There's the aquaculture industry, there's the recreational fishing industry, that are similar, but they do have sort of a different economic structure that does provide a service to the regional economy more broadly. So I do think moving forward, that would be a great addition of you have this estimate of how the commercial fishing industry could change. Well, what about all the rec guys that are out there that are fishing for the striped bass, which also are affected by changes in eelgrass and SAV populations as well. So none of this exists within a vacuum. You know, all of these industries benefit from each other, or they affect each other in some way. We need to find a way to kind of expand beyond just one industry and tie it into all of the others as well. I really do think that would resonate with policymakers, especially right now where money is a key topic.
Mm-hmm. Yeah, what I really liked about your paper was I sort of hadn't made the connection of how oyster restoration and SAV restoration are linked. Like
Mhm.
I really appreciated that part of it. It was really
Cool.
interesting. But Bill, if you had anything to sort of add to your arsenal of
Yeah.
influence, what would it be when you talk to people
Mm.
about aquaculture?
You know, uh, to me, it's interesting to follow on your question to Matt. I think that when the shellfish aquaculture industry is going and talking to decision makers, they have found that the economic impact of their industry is very important. Whereas a lot of the people who work around it are so impressed with the environmental, like, this is amazing. We're raising food and there seems to be a net benefit to the environment. Like um, I will say, I think that one of the things to add certainly is this idea that if Matt hypothetically were a shellfish farmer, and I want Matt to succeed at his business, and that's great. But I also think it's important to start quantifying the benefits to other members of the community of his work. If he's providing a public benefit, even if it's not necessarily getting nutrient credits but just recognition that the waterway may be net better off with his farm. That's I think a powerful way to go. And you could even turn that, as Matt has done with restoration, into the economic benefits to the public because there are potentially improved fisheries, improved water quality that are happening because of that farm. So I think that would be probably what I would start to. That's where I would like to expand our understanding and have better numbers for that.
Hmm. And I think maybe both of you can address this because you did so much economic analysis of your costs to the watermen and everything, Matt and Bill, you know a lot. Like, are the how big are the margins? I mean, how difficult is it to, have a successful operation?
Yeah, yeah, that was actually a main thing that a lot of the watermen I talked to brought up was the margins are already relatively thin, and they're getting thinner, because operating costs have gone up, materials costs for crab pots and um, motors and things has gone up, whereas the the gain, the dockside sales have not necessarily increased to the same level. Now that was a few years ago, but I'd assume that's the same situation. So I get the feeling that margins are relatively thin for a lot of people in the industry.
Hmm.
Yeah, I would second that, and I risk here that there are very possibly commercial farmers on the call here that could speak to this better than I would, and I'm not. But generally, my sense is that you can make a living at it, but it's typically not so much that an investor from Shark Tank will come in and see a way to make a lot of money without doing any work just by investing in it. Like owner operators can make a living at it. You can be somebody who works on the farm and you can make a living at it. But um, they're they are to me, it is a completely viable way to make a living in a community. But the margin, but it's work, and there's risk, and so the margins are fairly close. I think whether it's a commercial, somebody who works on the water commercially as a fisher, or whether it's a shellfish farmer, I think that's probably true.
In the couple of minutes we have left, I'm going to ask each of you to, if everybody on this call can do one thing to support restoration or shellfish aquaculture, what would you like people to do?
Yeah, just one thing. There's only one, right?
No, no, you can have more than one.
Yeah, no, I mean, I do think education is really important, right? We've talked a lot about ecological and economic benefits today, but the reality is that people aren't directly around this. Maybe they live in the bay, but they're not living right on the bay. They may not know why aquaculture is important or why restoration is important, but they might see the price tag that it takes to be successful at it. And I think that's a big challenge is how do we get people to accept that these things cost money, right? Like restoration costs money, monitoring costs money, science, it costs money, but it is super important and it can benefit our society and benefit us economically. Um, but we need to educate people and communicate appropriately that these things can actually have a benefit to their lives as well.
Thanks, Matt. Bill?
All right, I'll go with a non-intuitive one then, because that is totally right and it's intuitive too. I'll go with non-intuitive. For people who are used to restoration, I would say eat more shellfish, and because the shellfish that are in the marketplace are being harvested, these shellfish farmers are harvesting them in a sustainable way, and one way that you can support that is by eating more shellfish, and it's good for you. So.
So more shellfish and more blue catfish.
That's right.
Wow. Well, thank you very, very much.
Thank
That
you
was
all.
really wonderful. And for everyone on the call, thank you for your thoughtful questions and engagement. And join us on Wednesday, May 21st for our next roundtable. Thanks, Matt and Bill.